In this video, I'd like to share with you different expressions or different computations that can be made by using the unit circle. Now, these types of results can be found rather quickly if you have the unit circle memorized. So if you haven't memorized your unit circle yet, I suggest spending some more time doing that and then revisiting this practice. So on the right-hand side, I've got a collection of expressions that I'd like to evaluate, and on the left-hand side, I'll show you my work that I would do to complete these questions. So for number 5 in this first block, what I would first do is I would sketch a small unit circle, and then I would try to locate this position. Now, 2 pi over 3 is a radian measurement. There's no unit provided, so I assume that it's radians. If there was a unit provided, which actually I don't see in all of these examples, then it would specify degrees. But that's okay, we could use the practice. So 2 pi over 3 radians is positioned right here. This is the first position past vertical on our unit circle, and it would be associated with the angle measure that sits here. Now, I don't normally draw that angle when answering these questions. I just wanted to make it real clear where I'm looking. I'm focusing on this coordinate right here. I know that sine of 2 pi over 3 is the y coordinate. Sine is always associated with a y coordinate associated at this position. Now I know that the y coordinate at this position, because I've memorized the unit circle, is radical 3 over 2. So therefore sine of 2 pi over 3 is radical 3 over 2. For part B of 5, we're again using the same angle measure. This time we're asking for cosine of 2 pi over 3. So again, we're dealing with the same position, and I'll get rid of that arrow because again, I tend to not use the arrows here. I'll look at the coordinate itself. Now, cosine is asking for the x value at that position, and the x value in that position is negative 1/2. The cosine of 2 pi over 3 is equal to negative 1/2. Now, it is worth noting, too, that the same question could have been asked, sine of 120 degrees or cosine of 120 degrees, because a 120-degree angle is the same as a 2 pi over 3 radian angle, and in both cases, the results would be the same. Sine of 120 is radical 3 over 2. Cosine of 120 is negative 1/2. For part C, we're being asked to evaluate tangent at 2 pi over 3, and I know that that's going to be our y-coordinate divided by our x-coordinate. Maybe I'll give myself a little bit more room to work. So we've got radical 3 over 2 divided by negative 1 over 2. Well, as it turns out, these 2's that are both in the denominator of the fraction will cancel. We can see that if we illustrate it this way. Radical 3 divided by 2 divided by 1/2 would be the same as multiplying by negative 2 over 1. And when you multiply by the reciprocal instead of dividing, you can clearly see how those two values are going to cancel. And we're left with negative radical 3 over 1, or just negative radical 3. And that would be a good answer for part C in problem number 5. For problem number 6, it looks like we're dealing with the angle 5 pi over 6, and we want to evaluate sine, cosine, and tangent at each of those. So for problem number 6, I would sketch this circle, and I would locate 5 pi over 6. Well, that's this position here. This is the last angle measure before going horizontal. So in part A, if I need to evaluate sine at 5 pi over 6. I'm looking for the y-coordinate at this position. And while my sketch isn't very accurate, I do remember by memorization that the y-coordinate at this spot is 1/2. The b value, question B, is cosine of 5 pi over 6. So the x-coordinate in that position is negative radical 3 over 2. And tangent of 5 pi over 6. Well, that's the y-coordinate divided by the x-coordinate, so y divided by x. And you'll see this with shortcuts, or as you complete many of these, the 1/2 divided by radical 3 over 2, the 2's will cancel, and we're left with negative 1 over radical 3. If you are accustomed to rationalizing the denominator, you'll multiply both the numerator and the denominator by radical 3, and you'll end up with a solution radical 3 over 3, negative of course, and that would be okay as a solution as well. So question 6 is now complete. Question 7 differs slightly from part to part. Question A is asking us to find sine of 7 pi over 6. So I'll sketch a quick unit circle, and I'll note that 7 pi over 6 is this position down here. It's the first one beyond horizontal. And the y-coordinate in this position is negative 1/2. For part B, we're being asked to evaluate sine at negative pi over 6. Now, we haven't talked much about negative angle measures yet, but I'll point out here that a negative angle measure simply means a clockwise rotation instead of counterclockwise rotation. So normally pi over 6 would be the counterclockwise position here, but if we measured clockwise rotation instead, then we're talking about this angle measure down here. And instead, we're talking about this coordinate at that position. So at this position, this coordinate down here, we've got a y-coordinate. Again, we're looking at y because of the sine function, and that y-coordinate is going to be negative 1/2. Sine of negative pi over 6 is also equivalent to the y-coordinate at 330 degrees, or 11 pi over 6. Those are all the same. Finally, for this particular question, C, sine of 11 pi over 6, well, we just discussed that. Sine of 11 pi over 6 is the y-coordinate at this position, and that too is equal to negative 1/2. As far as work goes to show for these problems, the only work at this point is, if your unit circle is memorized, is a simple sketch of the unit circle. As we get further along with our work in this unit, you could probably answer a lot of these questions just in your head without showing any work whatsoever, and I'm perfectly fine with that. So hopefully you get a feel for how I approach each of these problems. I think what I'll do next is put a few questions up on the screen and pause the video. I'll let you try some of these problems on your own, and then I'll also put up on the screen my methods for solution as well. So for right now, let's take a look at question 8, A through C. Pause the video and try these on your own. Resume playback in a moment to check your work. Now, as it turns out, in question 8, all solutions are 1/2, but we arrived at them at different ways. Part 8A is a traditional question. We have a counterclockwise rotation of 5 pi over 3 radians, and that puts us in this position. So the x-coordinate there, of course, is 1/2. For part B, we have to go through a counterclockwise rotation, and that's what this blue ink is trying to show. We're counterclockwise rotating 5 pi over 3 radians, so that puts us here. That too has an x-coordinate of 1/2. And then finally, 7 pi over 3, well, 6 pi over 3 is a full rotation, so 6 pi over 3 would have put us right back at the positive x-axis. So 7 pi over 3 is 1 pi over 3 rotation beyond. So in my mind, I'm thinking 7 pi over 3 is really the same as 1 pi over 3, and 1 pi over 3 is still in this position with an x value of 1/2. So with that expressed, try your hand at number 11. Pause the video now and resume playback in just a moment. So in question 11, the position is all the same. 7 pi over 3 is the same as 1 pi over 3. So the y-coordinate for that position is radical 3 over 2. That's a good answer for 11A. The cosecant is the reciprocal of the y-coordinate, so it's reciprocal of sine. So I wrote down 1 over the y-coordinate. And I also noted that the reciprocal just means to flip the fraction, so you can report it this way as well. For cotangent, I needed the x-coordinate to be divided by the y-coordinate, and the x-coordinate of 1/2 divided by the y-coordinate of radical 3 over 2 would have the 2's cancel, and we're left with 1 over radical 3. Please try number 12 on your own and resume playback in a moment to check your work. And here again, the position is the same for each of these three problems. The position negative pi over 3 is a rightward or clockwise rotation from the positive x-axis. So that puts us in this position here, just before vertical. The x component of that position for cosine is 1/2. Secant is the reciprocal of cosine, so we could flip the fraction 1/2 to produce 2. And then finally, tangent at this position, the y value divided by the x value. Well, the y coordinate is negative radical 3 over 2, while the y coordinate is 1/2. And when we simplify, because the 2's cancel, we're left with negative radical 3. In the final stanza of this video, I've got 3 problems. Go ahead and try all 3 of them and resume playback in a moment to check your work. Now, before I note the solutions, here are diagrams for each of the problems. And I'll also point out here that 11 pi over 3, well, that's a full rotation of 6 pi over 3 plus an additional 5 pi over 3. So the result is the same as the position, 5 pi over 3. The others have been marked, and hopefully you can kind of interpret the way I'm showing my work here. I'm trying to place this point closest to the vertical or on the vertical where it lands. Now, with these positions in mind, you can solve the rest if you haven't done so already. And the solutions to these examples are as follows. In 15a, I'm thinking about the reciprocal of cosine, so the reciprocal of the x value. Well, the x value is 1/2, so you flip that and you get 2. For cosecant, that's the reciprocal of the y value. The y value flipped here is negative 2 over radical 3. And remember, when we flip these, when we find the reciprocal, we're just flipping the fraction. We're not changing the sign, so it does retain this negative symbol. For part C, we are flipping the x-coordinate. So again, the x-coordinate was 1/2. The reciprocal of that is 2. For 16a, the x value at 7 pi over 6 is negative radical 3 over 2. And the reciprocal of the x value is negative 2 over radical 3. So same position, just the reciprocal when asked to find the secant instead of cosine. For cosecant, we want the reciprocal of the y-coordinate. So the y-coordinate is negative 1/2. The reciprocal of that is negative 2. So those all check out. Now finally, the tangent would be our y-coordinate divided by our x-coordinate. Y, of course, here being 1/2. Divided by the x-coordinate, negative radical 3 over 2. So mentally I recognize that 1/2 over radical 3 over 2 would force the 2's to cancel. We're left with 1 over radical 3. Retain the negative symbol because that does not disappear. For the tangent of 7 pi over 6, we want the y-coordinate, negative 1/2, divided by the x-coordinate, negative radical 3 over 2. Those two negatives will cancel, and we're left with 1 over radical 3. For the last value, the y-coordinate, negative 1/2, divided by the x-coordinate, positive radical 3 over 2, does produce the fraction negative 1 over radical 3. Keep in mind that whether you write the negative sign in the numerator or the denominator doesn't matter. As long as there's one negative symbol included, these two are equivalent. So tangent of 5 pi over 6 is the same as tangent of 11 pi over 6. Now, personally, I'm a big fan of memorizing the entire unit circle. But if you're having trouble memorizing the entire unit circle, what you could do instead is memorize just the first quadrant. And if you locate the coordinates of the components in the first quadrant, including the boundaries here, you could figure out the equivalent positions in the other 3 quadrants. You could easily sit and figure out what the remaining components are. And if you choose to go that route and think about your trig results that way, a phrase that's often helpful to remind you of which trig functions are positive in which quadrant is the phrase, all students take calculus. If you remember that phrase, all students take calculus, then this could help you remember, again, which trig functions are positive in each quadrant. And if you start in quadrant 1, so all students come from quadrant 1, this tells me that all trig functions are positive. The phrase students in quadrant 2 implies that the sine or cosecant function, because sine and cosecant are reciprocals, they don't change their signs or symbols here. So sine and cosecant are positive in the second quadrant. The phrase take is referring to the third quadrant. All students take. So in this case, we know that tangent and cotangent are positive in the third quadrant. And the phrase calculus for cosine or cosine and secant, those values are positive. So where are trig functions positive? Well, again, recall the phrase all students take calculus, and that'll help you recognize that. The way I would use that in this situation here is that I would recognize that 5 pi over 6, well, that's an angle measure in the second quadrant. And since I'm asking to evaluate tangent here, then I should come up with a result that ends up being negative. At the angle 7 pi over 6, well, 7 pi over 6, that's a position in the third quadrant, and tangent, when evaluated in the third quadrant, must be positive due to this phrasing. So to see a positive result here is a good sign. No pun intended. So I hope that helps with practicing just a little bit. If you've got any further questions on how we can use the unit circle to evaluate different trig functions, please let me know. And any other questions, of course, you can send my way as well, and I'll try my best to answer them as soon as I can. Thanks for watching.